to the Zoom. Okay, sorry for a bit of technical issue. Let's continue with the session. Right, so I mentioned this before. Navigation is a very important component because it is used for user to navigate between screens or pages in the app. But it is also worthy to mention that in mobile apps, there is also another mechanism called deep links. This is used for letting integration, or not integration, it is letting an app to share or to let in the interaction within the app to transition or to use a page from another app. Maybe this is not apparent, but for example, let's say you are using Discord, for example. So you are using Discord in your mobile app, and then somebody shared a link to a document on Google Drive. And then you click that link. So deep link mechanism is able to make a link or URL to be recognizable by an app in your mobile app. So if somebody click that link, that it will trigger a transition from your Discord app to opening the document in your Google Drive app in your mobile device. Or suppose that you are currently on WhatsApp, or WhatsApp, and then you have a picture that you want to share to your friend in Discord, also in the mobile device. So, so when you share that, when you open the share feature in your WhatsApp, the sharing window in your mobile device, whether it is Android or iOS, will pop up and ask you what app that you want to share this picture with. And if you choose to share with Discord or share with other applications like Line, that can be done. And then your exact image will appear in the message composition widget in Discord or Line, for example. But yeah, this mechanism, deep link mechanism, won't be covered. And if you want to learn more about this deep link mechanism, there is an elective course called Mobile Programming here in the Faculty of Computer Science. If you want to, you can explore it on your own, or you can take this elective course that usually offered in even semester, I suppose. But in short, for most of the time you will use navigator component or navigation, but there's also exists another mechanism called deep link that lets you to transition your screen, your app screen, to another screen that is provided by another app in the same device. So let's go back to navigation component and see what it offer us. So first we have navigator. This is you already familiar with. And navigate, to be more specific, although the explanation that I gave you last week is using analogy of stack of screens, but it is more correct that it is not only about stack of screens or pages, but it also includes the routes, like the direction to the screen. So it's like the direction that tells the mobile platform, the Android or the iOS, what screen to load in the device. So the stack of the navigation, i.e. the pages or the screens, contains not only the screen, but also the routing information to that particular screen. So navigator is the one that's responsible to manage the route and also to transition the screens. And then there is also another component called overlay that specify the appearances of the routes. And the route itself is the navigation endpoint. It's similar to the idea of having a URL or link in web application. But route itself is the implementation in mobile app that dictates the navigation between screens and also possibly containing additional information that needs to be passed down from a screen to another screen. By default, from your last tutorial, the route that is processed by the navigator object is simply a route to transition the screen, right? But it is also possible to include information as part of the route so that when the next screen is loaded by the navigator, the information passed through the route can be included or displayed in the new screen that is displayed by the device. So yeah, you're already familiar with this. Navigation is made in a stack structure, and you can view it like a stack of pages or screens. So each time you click a button, well, not a button, user interface element that specifically made the user to go to the next screen or page, then the mechanism will similar to how stack operates. So the existing page will be pushed down into the bottom of stack. Well, not the bottom. Well, the current page will stay in the top of the stack. However, when the user transition to the next page or screen, then that next page will be pushed on top of the stack. So it follows with the illustration in the slides. So previously, your first page is currently the top of the stack. And then when you transition to the next page, then the next page will be put on top of the stack by using push operation. So when you push it to the stack, when the user transition to the next page will be put into the stack, like using push operation. And suppose that when a user click the back button in their device or explicitly return back to the previous page, then the navigation will use pop mechanism from the stack. So the screen, the currently active screen will return to the first page, for example. So yeah, you can view the navigation mechanism in mobile app similar to stack, but you don't have to go further. I mean, This way of mechanism is actually similar to what you have usually used in web browser, right? So, for example, when you use a web browser, and you see here in the back button, web browser implements similar mechanism to track the pages that you have visited. And yeah, it's essentially a stack, right? So each time you open a new page, the previous page that you access is put into the stack of pages that you have previously visited. So it's similar. The idea is similar. And how to do it? Well, you have already done that in the tutorial. So you use the push and pop method provided by the navigator object. However, there is also another variation. If I remember correctly, it was called the push and replace. Is it? In the tutorial, use the different, provide you with different push method. This one, push replacement. What it does is, well, it sounds exactly as the method's name. That is, it push the page, but also replace the top of the stack at the same time. So it's like replace whatever currently on top of stack with this new page or screen. And yeah, this is the example. You're already familiar with the example from the previous tutorial. So yeah, that wraps up the navigation component. So yeah, this is the mechanism that is used to let user navigate within their apps. So in order to achieve that, you need to use navigation component. It's different from what you have learned in web application development, right? To let user navigate between the pages of your web app, you have anchor text and links that will tell the browser to open the next page. But in mobile app, specifically in Flutter, you need to use this navigation component in order to let user to transition or move to the next pages or screen that they would like to access. Any questions so far regarding the navigation, or if you have any trouble or issues with the tutorial or assignment, you can also discuss it here in the classroom. Currently none, okay. But yeah, if you do have questions, you can ask it directly to Zoom or use the provided link on top of the slide if you probably shy to talk or chat using Zoom. Okay. The next part is asynchronous call. Yeah, do not afraid with asynchronous call. I know this is a challenging topic, but yeah, this is a necessity because, well, the nature of interaction between application and systems out there are inherently asynchronous. So inevitably, we will have to deal with this asynchronous nature of apps interaction between other apps or even with other systems. So the prime motivation to know more about asynchronous call is we need to make the app to deal with data that come from different sources, and that data might not necessarily come instantly. Yeah, for example, if you open Twitter, the data is needs to be computed first, right, at Twitter's side or Twitter's backend, and eventually those data will processed successfully on backend and then transmitted to your web page or to your Twitter front page. So notice that when you initially loading Twitter, there is an indicator that's probably indicates that the data is currently loading. And once it is done, it displays the data that comprise of whatever these things that sent by Twitter to my web to my browser. So data might come not synchronously or immediately to your app. So you need to be aware of that. So what happened is if we don't care about asynchronous call, yes, we can load data in synchronous manner. So for example, you call a remote procedure call, or you invoke HTTP function from your app, from your Flutter code, and explicitly you require the HTTP or the web service call to finish first before you can do the next thing in your app. The consequences of not applying asynchronous call is if the data source is currently down or having performance issue, then your app will not proceed until it receives the data from the data source. And since you are not applying asynchronous call, your app stuck until the data is successfully transmitted from the data source. That is the primary motivation of doing asynchronous call, to ensure that the application is still interactive, i.e. can be used by user even though the asynchronous operation are still going or not finished yet. But yeah, another motivation is it's actually related to concurrency issues. So the thing with asynchronous call, data that may not come in instant time will be related with a larger issue called concurrency. But we don't really discuss this concurrency in this course. You will learn more about concurrency in the next mandatory course that you will take next semester, that is the advanced programming course. But the LDR, the short version of why we need asynchronous call, is to ensure the app is still interactive, even though there are probably several asynchronous operations going on in the background. And yeah, asynchronous call is not only for fetching data from a data source over network, but also writing or reading to a database and also reading data from a file. Because again, this has a common theme. We require asynchronous call that is when doing operations related to what is called as I/O, input-output. So that's fetching data and also writing to a database or reading a file. Those operations involve I/O, right? Input-output. And if you have taken up or currently taking operating system course and also have some awareness about how apps works from the user level to the bottom of the operating system and also to the kernel and hardware, I/O operations actually expensive, right? Especially if it needs to do I/O operations to a hard disk or I/O operation or from a network. The duration of I/O operations will be limited or clamped down to the performance of your I/O channel. If you are performing fetching data over a network, then the duration of that I/O operation will depend on, for example, your internet bandwidth, your internet speed. If you're currently using 4G network, then it will be fast. But if you currently somewhere around in the middle of nowhere in Indonesia, where you probably only have GPRS signal, then I/O operation of a network will be pretty slow. Similarly, when you reading a data from a file, it depends. If your file is in SSD, it will be pretty fast. But if it is in a traditional hard disk that's still using mechanical plates, then it will be quite slow. And if we want to avoid the app to wait for those I/O operations to finish, then we have to use these asynchronous operations. So we let the app to perform other operations while waiting the asynchronous operations to finish. Eventually, those asynchronous operations will finish and will do something to the app. And to do all of these things, asynchronous operations, we will use the concept provided by Dart, that is by using future class and also async and await keywords. So a future represents an operation that is conducted in asynchronous manner. So it's like, to provide you with an analogy with this, it's like you have a promise. So let's say you and your friend have a promise, like, hey, promise me that you will, let's say, go to my birthday party next week. So it's like you telling your friend that your friend will have a promise to have a promise to attend your birthday party next week, for example. And that promise, yeah, will eventually done by your friend, right? Either your friend will actually do the required things to attend your birthday party next week, or forgot to attend your birthday party. And in that process, let's say we still follow the analogy of having a promise. Let's say you ask your friend to promise you to attend your birthday party, then your friend will do any task related to attend your birthday party. For example, your friend might prepare a present or look for a new outfit, and maybe also invite other friends to go to your birthday party. And when you ask your friend to promise you to go to your birthday party next week, you simply tell your friend to, hey, promise me to go to my birthday party. That's the only thing you do, right? And once you have told your friend to have that promise, you can do other things. That analogy apply in asynchronous programming in using this concept of future. So you represent the operations that will be conducted in asynchronous manner as an object of future. That object of future encapsulates the asynchronous operation that needs to be executed by the framework or by the platform. And then this future object will have two possible states. It's similar to promise, right? So either the promise is still ongoing or not completed, or the promise is actually completed with success, failure, or with an error. So when the promise or the future is still in the state of incomplete, it is still waiting for the asynchronous operation that is encapsulated in the future object to be completed. So it just tells us that the operation is still ongoing. However, the completed states mean the encapsulated of asynchronous operation in the future object already finished and possibly containing a value. Therefore, it can be queried or accessed for further processing. It is also possible, though, that the feature that already completed resolved to an error. And that happened, right? So, for example, if you invoke asynchronous operation to open or to retrieve a collection of JSON objects from a URL, the status of your asynchronous operation is either successfully retrieve all of those JSON objects from that endpoint or from that URL, or the operation failed due to the URL or the endpoint is currently down. Either way, both operations complete, resolve to a value. However, yeah, the first one is successfully executed, and the latter is completes with an error. So, yeah, a feature can complete, but the final result could be a success value or an error. So, for example, in Dart, this is how feature is implemented. Well, not implemented, it's used. So if you want to have an operations that is will be done in asynchronous manner, then you have to declare the data type of your function to return a future object, followed by this. Future of string or future of void. I remember. I know most of you did their program foundations too in Kotlin. Is this syntax familiar to you? The data type then and then followed by angle bracket and then a data type and then plus angle bracket. Are you familiar with this syntax, or is it present, this kind of syntax in Kotlin? So you can declare a data type and then followed by angle brackets, and within the angle brackets you mention another data type. Okay, so Kalush mentioned that in private message that you already encountered this in Kotlin, right? So this is called as generic type. Let me. So it is called as generic type. So by design, the future object, the class of the future class is a generic type, meaning the instance of future will have one of its instance variable to be specifically contain the type defined in the declaration of the future object. So for example, feature of string here means we would return an object of future that contain a string object in the future object. In separate example, feature of void here means we will return an object of future that doesn't contain any particular data type that will be encapsulated in the future object, meaning it will perform an operation without returning any data. So this is a generic type, so you specify what kind of data type that will be enclosed or encapsulated within the future object. If you are going to return a string as a result from the asynchronous operation, then you declare your future as a feature of string. Similarly, if you want to encapsulate asynchronous operation that will not return anything, or so you can declare your feature as a feature of void. So yeah, it's generic type. It is not only used for feature, right? If you have learned this from previous programming courses, generic type is also used to make your class to be more flexible while maintaining a proper data, while maintaining proper strong data type mechanism in the class. So you can specify the data type that will be enclosed in an object. So you don't have to, for example, create like a specific data container classes for every possible data type. That will be very tiring, right? Imagine that you have to create separate list classes for containing integer and then another list for containing string, etc. By using generic type, you can have one single definition of list where the data content in that list can be determined or defined dynamically by using the type, by using generic type. But yeah, a more further discussion about generic type is can be referred to another course, right? You most likely will learn or have learned about generic type from Programming Foundations 2 and or from data structure class. So yeah, let's go back to the feature. So in short, you have feature that will contain a value produced from the asynchronous operation. Now, the asynchronous operation that I frequently mentioned from earlier actually implemented in the body of the function. So if we look at this example, the operation here, it could be as simple as you performing some kind of programming statements like doing iteration or invoking functions. But It could also contain another asynchronous operations. So in the first example here, in the print order message, you have a function that will return a feature of void. So in other words, this function will perform an asynchronous operation that will return nothing. And inside that feature, the function will do the following. First, it will print something to the console, like awaiting user order string. And then the next operation is it will invoke fetch user order, which actually another asynchronous operation. And if we look at the fetch user order, it is an asynchronous operation that will return a string. And the string that will be returned is a string that eventually produced after delaying the operation by 4 seconds. So after 4 seconds, this function will return a string, a large latte as string. And once it is completed or resolved, that large latte will put into the order variable, and then the order will be displayed on console by using print function. Any questions so far regarding future async and await? Not yet. Okay. I noticed I only explained about future, right? I haven't explained about async and await. Async and await are keywords, and yeah, this is quite interesting actually. This notion of async and await become more apparent in relatively new programming languages, and even in old languages like Python, async and await are a new keyword. So if you have ever used Python before, traditionally Python didn't have async and await keywords previously. But since Python version, I forgot which version, but async and await are actually a new keyword in Python programming language. And exactly the reason why async and await introduced into Python are to accommodate this new way of programming. Well, not relatively new, but since asynchronous operations become more popular, or the use cases for using asynchronous operations become more apparent nowadays, some programming languages begin to introduce this async and await pattern as their feature in the programming language. And that itself, already include this async and await pattern. What it does is, first, await is to tell the program that is the value from the function eventually will be produced. So in the statement that in the first example, the variable order equal to await fetch user order, it means that the statement needs to await for the fetch user order to finish, and until then, the execution, the program execution will continue on executing different codes in the program. So it's like we tell the program that there is a piece of code that will need to await before it can proceed further. And if it is done, the value will eventually resolve and put into the variable. Async, in other hand, it's like a modifier or a flag for a function to be executed as an asynchronous operation. So it's like when the function is labeled as async, it tells the runtime that this function can run as asynchronous operation. Therefore, it can be put on hold in order to resolve other operations that currently waiting to be executed. Maybe it's, I need to demonstrate this in that, but okay. Is there any example that's specific for the async? Oh, not yet, but similar one exists. So in the example in that path, we have this void main method or function labeled as async function. That means the function will contain asynchronous operations in it. So for example, this is a URL. So it uses this URL.https to construct the given URL into HTTPS URL. And then it invokes this http.get. And the .get itself from the HTTP library is a function that will return a response object in a future. So this get invocation will perform a HTTP GET request to the given URL, and then the response itself will be contained in a future object. So it is an asynchronous operation. And whatever the result from the http.get will be put into the response variable. And then at the next code, it checks the status code of the response. If the status code is 200, meaning it is successful, then parse the JSON that contained in the body's response into an object recognized in Dart. And that object will have some properties such as total items, and the total items will be parsed in and stored into the item count variable, and then print it. So the main function is labeled as async in order to accommodate any asynchronous operation that will happen in the body of the function. Then the HTTP get here, since it will produce a feature containing a response, it will invoke an asynchronous operation that happen, and we use await to tell response, the variable that will contain the value, to eventually obtain the result of this asynchronous operation result. After that, it continues to perform further operations like to check the status code. Maybe this not clear yet, but I think this is a good time to return back to history. Why this pattern is apparent or become more the recommended way to handle asynchronous operation. Previously, let's say, suppose you are coding JavaScript again, you maybe still remember that when you invoke jQuery like .get, and then you have to put the some URL.com as the endpoint. In jQuery or ordinary JavaScript, vanilla JavaScript, this was the pattern that you have to implement to handle asynchronous operation. So you invoke a method or function, and then you pass down a function. This pattern is called as a callback. So in callback mechanism, we invoke a function or a method that actually perform asynchronous operation, and then at the same time we assign one or more functions that will be executed based on the result of the asynchronous operation. So for example, the callback to this get call in JavaScript, in vanilla JavaScript using jQuery, usually related to the function that needs to be executed once the data successfully obtained from the targeted endpoint. So in the callback, you probably do obtaining the reference to div, then you append something based on the content of the response. And also the callback contain not only the function needs to be executed once the asynchronous operation is successfully handled, but also we can add the callback function that handle error situation. And then we can implement the procedure to handle error here. Maybe as simple as logging the error or producing error message to the user interface. This is one example of callback pattern in a simple asynchronous operation. But you may have noticed that asynchronous operation may get nested, right? Let's say after the program obtained a data from this URL, the program needs to fetch another data in order to combine them into this single view. So after performing callback in this, you make another jQuery call or vanilla JavaScript to call another API. And then again, you have to provide a callback. And once, and it's possible the callback stacks gets pretty deep, and it makes the code kind of hard to read because the callback stacks can become quite deep. And in order to debug that, you have to go to trace each callback function and also to simulate, try to make the application able to simulate a specific error condition in order to trigger a specific callback function deep in the callback stack. And that actually have its own term that is called callback hell. So that the pattern that I illustrated just now can lead into what is called as callback hell. The callbacks are quite a lot in the function. So due to that common occurrence of, I suppose it is can be called as anti-pattern, async await, come to the rescue. As you have seen, instead of requiring the programmer to assign a callback here, asynchronous operation can be written as if we are writing a traditional imperative code. So it's we don't have to have a nested callback anymore, because we can write the code similar to traditional imperative code. So let's say http.get, it is an asynchronous operation that will return an object of future. And in the code here in line 17, we just simply invoke it, http.get URL, and then we await. And we know the result eventually will be produced and stored in the response. And the status of the future can be inferred from this response. So we can perform a conditional by using, we can perform a traditional conditional check against the result of the future. So we can use if else to check the condition of the result So we can the main takeaway is we can avoid the anti-pattern that requires the programmer to declare callback functions to handle situations that may occur in asynchronous operation call. Not only for successful call, but also failure states that can be resulted from asynchronous operation. So that one a slightly bit history lesson why this async await become more popular. And as for this example, well, let's try it. So we have this feature wait name async count seconds for, and we have count seconds method s that is, yeah, just hide it. We can iterate for var I equal to 1, I less than or equal s plus the duration of seconds. Delay, yeah. Okay. So what happened here? We have this feature name, and then it invoke count seconds. And the consequence will, perform this asynchronous operation where the print, okay, let's try it again. So it will like print the message, the number to the screen. And then at the same time, it will await for order message. And the order message here is a feature of void. Then just hide the issue of the message. And then it from asynchronous operation, awaiting user order. Await another operation, and lastly print something. Your order is the order, and then last fetch user order. Going to delay it. So we tell the async operation to delay for 4 seconds, and after it wait for 4 seconds, it will produce this string. It is an error. Okay. Then go 4, and your order is large latte. So the main invoke this count seconds for 4 seconds. Well, not for 4 seconds actually. So if we look at the iteration here, the seconds value here defined by the current I value here. And then the await here okay, let's go through the example again. So it awaiting user order, and then notice that the count seconds executed first, right? So the count seconds executed, and since this method doesn't have explicit asynchronous operation, it what is it called in English? It will take the main execution of the program to handle this iteration. So although we have this, I mean, we already invoke this count seconds, and the count second is delayed for initially 1 second. It already immediately processed this print order message, right? So it already goes to the print order message, and it print the awaiting user order, and then it awaits concurrently with the count seconds. So while count second is still producing string to the console log, the fetch user order is currently executing as well. But since the execution is currently as simple as making the function delayed for 4 seconds, it won't do nothing. And notice that the sequence of the program sequence here is kind of like suspended. So even though we have executed this line, number 7, the program execution in the print order message is suspended at line 8. Because it's still waiting for the delay to be resolved or to finish and produce large latte string. And once the delay passes, the fetch user order produce large latte, and then the sequence is continued to execute the next function. What happens if the seconds is set to 1, for example? Let's try it. So this is interesting. Again, we have main method or main function, and then count seconds is executed. Now, count seconds is executed, and then main also move to the next statement, that is to execute print order message. And then in the print order message, it's similar to the previous example. It executes awaiting user order and then wait for the user order to finish before the execution proceed to the next statement. And since the user order only delayed for 1 second, notice that the program flow immediately produce your order is large latte after the count seconds only proceed for 1 iteration or 1 step. And then this already finished. So the print order message already finished after your order is large latte is produced to the screen, but then count second is still proceeding. So notice that the count is still going on. 2, 3, 4, and then the execution ends. So yeah, this is a kind of probably a new technique or new concept for to be applied in programming. Traditionally, when you learn about programming, you see program may only have 1 single flow of execution. But now we are dealing with a program that may have multiple execution flows. But for now, the common use cases for using async and await pattern here to handle I/O operations. To learn more about async and await or the larger issue that is concurrency, I suggest you to take advanced programming course next semester. But pragmatically, this async and await pattern is used for handling asynchronous operation that often occur when we are dealing with I/O operations, and also other operations that may be computationally expensive or may take longer time than usual. Okay, any questions regarding async and await pattern? So I explained the historical motivation, that is the issue of anti-pattern callback hell, and by using async and await, we can avoid that callback hell by making the code can be written as if we are writing a traditional imperative code. Okay, if there is no question, let's move on to the next part. Yeah, integration to web service. So eventually, again, if you want to make app that is useful, pretty often you have to integrate your app with other application, right? And that application may be a web service or another Django application that already deployed on the internet. And in order to do so, well, we have to use this HTTP package or similar package that may be available in Dart package ecosystem. So HTTP here is only one example of Dart packages, right? So let's see. We have this central repository called pubdev, and this pubdev may have several packages. So for example, this HTTP is a package published by dart.dev. We can see the information. Who is dart.dev? Well, dart.dev is core packages published by the Dart team. So we know that this is a package that is officially developed by Dart developer. Okay, so that's one example. We can also see other packages. So for example, let's see. This is interesting. Chopper. Well, this is a package for HTTP client generator for Dart and Flutter. Well, I'm not sure whether you are going to use this, but by its name, it's interesting. Let me see. What is it for? Oh, I see. Okay, this will be related to the next tutorial. Later on in the next tutorial, you will learn how to receive HTTP, will receive a JSON response from another web application and then use it as data in your Flutter app. One way to do that is you receive the JSON from the API, and then you manually parse it into an object in Dart language. And then you use that object to become the data object that will be rendered by your widget in Flutter. However, there are also other alternatives, like the package that I show here. So this package is sort of let's see. It's like the component that will perform the request to the target web API or web application that will return a object, that will return a JSON object. And that request can be converted later on into no, not the request, but the response can be converted to become the object in your Flutter, in your Dart and Flutter code. But yeah, let's return to the issues of packages. Okay, so in short, we have this collection of Dart packages. And what you need to ensure that every time you install a new package, make sure you are able to verify the author, and also make sure the name matches. Because I'm sorry, I have to kind of what is called in English, detour from the course material, but this is actually important. Nowadays, it is pretty often to what it is called to attack a web application or an application to be more general by conducting what is called as package name impersonation. So let's see. For example, this is HTTP package. It's pretty simple, right? But let's say we have a security issue. IP. Let's say there is someone out there attempting to impersonate a package name, a popular package name. Like instead of HTTP, they created a package called HTLP. L and T look similar, right? When rendered on web browser. Or instead of HTTP, they write another package called HTTP. So triple T's out there in the package name. And they hope whenever a developer would like to install HTTP package, they perform a typo. So instead of including HTTP, they include HTTP. And suppose that happened, and the worst case that can be done is, while the HTTP may be performed exactly similar to the original HTTP, but the code may contain something dangerous. Maybe they have piece of code that will copy your cookies in your device or any user sensitive information like your name, your email, etc., and then send it to their own API so they can capture those information from within the application that mistakenly included HTTP package. So this one issue related to external software packages become more popular recently. So what I'm going to say is, please make sure you are able to verify the basic information of the packages that you want to include into your app. Make sure you don't perform typo. Make sure you actually know the publisher or the author of the package. And even better, if it is an open source, you can also check the source code. So for example, we can see the source code of the HTTP package on GitHub. And we can actually verify whether the package actually performed what it advertised to. So yeah, go back to the course material. You can install packages in Dart and Flutter by modifying this pubspec.yaml file. It's similar to the requirements.txt file that you use in Django project. It contains the list of packages that required by your app. So let's see. In the HTTP package, we can define HTTP, and then we specify the version. And what is this funny looking symbol at front? It is called as, I don't know the actual term to call these symbols that pretty often come in the version number, but what it does is we'll install the package with given version as long, well, okay, so this head symbol will install the package, or in this case, we'll install HTTP package with version 0.13.5 or above, as long the minor and patch version. Okay, as long it does not what it's called update the major version. Okay, so this head 0.13.5 means, this is the actual term, version range. Okay, so the head symbol defines a version range that it will install HTTP package version 0.13.5 or above, as long the major version is still version 0. So what I mean by major version is this. The versioning mechanism in many packages system follow this format, major, minor, patch. So if we use head symbol, it means we keep the major version. So in this case, we keep the major version to be 0, and then the minor and patch can, if there are newer HTTP version that higher than the given version in the pubspec file, then it will install that version from the package repository. Yeah, turns out, well, currently there is only version 0.13.5, right, currently in the Dart repository. But let's say we use this. So we define HTTP with version range head 0.13.0, and when we execute or when we install the package, the package system will try to resolve this version range and then see the availability of packages in the repository. So for this example, let's see. So we requested to install 0.13.0 with version range symbol head. And then in the repository, it found that there is a newer version that is 0.13.5. Therefore, Dart will install that newer version instead, because it still matches under the version range. And similarly, there is another dependency like the Cupertino icons here. It mentioned it use head 1.0.2. It means if there are newer versions than 1.0.2, it will install that new version instead, as long the new version, the major new version, is still in version 1. And yeah, for your record, maintaining proper version is important as well. Or even if you try to ensure all of your developer in your team using the same package version during development, this kind of controversial practice, it depends on the team actually, but we can remove the version range symbol if we want to. This is to ensure everyone is using exactly the same package version. Because if we use this package version range, maybe today when you install a package, the package version is still 0.13.5. And then next week, when your team member join your team and then try to develop, when they try to install the same package, it turns out the package already been upgraded on the package repository to version 0.13.7, for instance. And then during development, you notice that there is a bug that you experienced, but your friend not. And that is possibly due to the new HTTP package that your friend used. But your friend didn't experience the same issue. So maybe during development, if we want to ensure everyone is using the same code, using the same packages, so if there is one issue happen in one person, it can be immediately known by the others. I think fixing the package version is better than using version range. So we know everyone is using the same package, using the same version. So if some things goes wrong, everyone knows it. And this also important when we try to ensure the app can be built at if we try to ensure the app can be rebuilt the same in the future. So maybe when we develop this app now, we would like to able to produce this exactly the same app without modifying anything in the future, maybe in next year. And if we use version range, then it is possible that next year some of the packages have changed there, and that might resulting in producing a different app and maybe also introducing issues that previously not existent in the app. So yeah, for now you can use this version range head symbol, but I personally prefer to just use what is called the fixed version without version range specifier. Right. When you imported a package that may requiring additional permission to the targeted platform, you also have to update the configuration of your targeted platform. For example, if you build an app that will require an internet connection on Android, you have to explicitly mention that your app is going to use internet capability in Android platform. So don't forget to update the Android manifest in your Android source code. Similar thing may also apply in iOS, but I don't have Mac, so I don't know which file needs to be updated. And yeah, when interacting using JSON, I mentioned before, you need to parse the JSON to become an object in Dart language. Or you can also generate the, what is it called? The boilerplate that lets you convert the JSON to Dart object. One of such tools that you will see in the tutorial is this app called QuickType. So in QuickType, you can type a JSON, and then based on that JSON, QuickType will produce the class representation for that JSON data. So for example, here I have recipe object, recipe data, and then by using QuickType, it is able to generate the basic class definition that can contain the JSON information. In addition, it also provides you with the factory method that will be able to receive the map of JSON data produced that you parse from the HTTP response, and then transform it into the object of the recipe or the object in that language. So this tool is quite handy, especially if you have to deal with API or developing a project in that quite large in size. And yeah, it's also interesting to see several variations in other languages. For example, in Java, see that it spread the verbose in order to create the class representation of the same JSON object. Well, arguably, the class representation is only this large, this small, but it requires quite a lot of boilerplate in order to convert the JSON to Java object. But if you see at Kotlin, it's pretty neat. It's quite short. So yeah, it's interesting to see the variation of generated class by QuickType in several languages. That is still quite short, so yeah, it looks nice compared to Java or C++. Okay, right. How many slides left? Quite a few, I guess. But yeah, considering the time, we kind of running out of time. But well, based on the slides, I think the remaining slides are more practical to be seen, to be covered in the upcoming tutorial session. So in the next tutorial session, you will actually practice how to invoke HTTP how to create HTTP requests and then receive the response and parse it into that object. So any questions so far regarding navigation, networking, or parsing HTTP response into that object? No questions so far. Right, so let's see online class attendance. I think it's, yeah, I have to set it to 12 p.m. So the code for today's attendance is YDSVCN. Oops, everyone to meet in the meeting. YDSVCN. So that's the code to label yourself as participated in today's class session. So I think that's all for today. Thank you everyone for attending today's session. So in Thursday, we will have a tutorial that focus on this aspect that will invoke HTTP, that will call HTTP requests, and then receive the response, and also parse the response into Dart object. And if I remember correctly, the TA also designed an additional topic for the tutorial so that you can also implement basic application authentication. So you can have your app to have a login screen that is authenticated against a Django application that you have developed from the midterm period. So yeah, look forward to it in upcoming tutorial session. So that's all for today. Thank you, everyone, and I will see you later in the next tutorial session. So goodbye, everyone. Bye-bye.